On a two other one. Choose on this one.
I'm gonna do this mention in one day, and I'm gonna split it into 2 days because today is short. And then I also was gonna give you a quiz just on chapter, like section 4.6, 4.7, 4.8. But I found out yesterday that we have to put my dad in a nursing home, so next Friday, I'm gonna be gone, doing that. So I think I'm gonna plan a quiz for that day. So we'll learn new stuff Monday, Tuesday, Wednesday, do like a practice quiz on Thursday, whatever we've done. And then I'll give you, you'll have a quiz when I got. And I just put in for the sub today, so I don't know who it is yet. All right, so we're gonna do this page and this page today, and then we'll do the last 3 on Monday. Great. So yesterday, what we learned at the end was how you could find what additional factors went into a polynomial. And today, we're still going to be using factoring. And I don't think today we do synthetic substitution. I think that's on Monday. But when you get a polynomial and they ask you to solve it, that means you have to do synthetic substitution sometimes if the powers are really big. And then otherwise, if you can factor it, you just have it there. And then the only other step that we do today that we didn't yesterday was yesterday we left the factors like this. And that was our answer. And today we want to find what X actually is. And do you guys understand that if it's X plus 3 and you set that equal to 0 and solved it, the answer would actually be -3. The answer is opposite in sign to that. Here I have X plus 5 equals 0. So to solve that, I'd subtract 5. So my answer would be -5. So when I go from here to my answers, I just take the opposite sign of this. So -3, opposite side of that, -5. Okay. So we're just doing that extra step today. One other thing they're going to ask you today is how many roots you have. Roots is like your answer. It would be the same thing if they said solve for X or find the X-intercept. Those are all roots, zeros, X-intercept, they mean the same thing. So they want us to find out how many, and they want us to find out how many of each type. So your choices are you're going to have real numbers, which would be any number that you're used to. It can be a decimal, a fraction, a positive, a negative. All of those are real numbers. It can be whole numbers. But the other type is imaginary, and imaginary numbers are going to have an I in it. Okay, so at the end, when we get done, we say how many we have and if they're real or imaginary. So let's go ahead and start with this one. Now, hopefully when you guys look at this, you would know that we could use trinomial factoring. And we put the x squared right here, the negative 48 here and here. And like I said, if you learn this a different way with a different teacher, absolutely do it the way that makes sense to you. Now, do you guys understand what two numbers multiply to give us negative 48 and add up to 2? 6 and 8. And which one would be positive?
8.
The 8. Because this is positive, your biggest one would be positive. Had that been negative, the 8 would be negative. And then 8 plus a negative 6 is 2. So one of these would be 8x, one would be negative 6x. Okay. Now, if this is x squared, we'd put x and x. If this is 8x, that's x, and this is 8. That's x, and this is negative 6. Okay. So our answers here would be, one would be x plus 8, and one would be x minus 6. And then, like I said, we take it one step further where we say what our x is. So we would say x equals the opposite of this, which is negative 8, the opposite of this, which is a positive 6. So that's one answer. The other thing we have to do is say how many answers we got and what kind there are. If there are no i's, and you'll see later we will get stuff with i's in them. If there's no i's, they're real. So you would just say you got 2 real roots. And they're real because they don't have an I in them. If they have an I in them, they're imaginary. Okay. Now, this one is one that I haven't shown you yet this week. And this is when you have a number in front of the x squared and you have to do trinomial factoring. Honestly, this is not something we do a ton of in here. I make up all your notes and all your tests and all your worksheets. And I don't do this much where I put a number in front of here. But I do want to show you how you would do that differently. So this is going to be trinomial factoring. The 2x squared goes here. The negative 6 goes here. And everything we did so far, if this was negative 6, that was negative 6. If you have a number in front of the x squared, it's different for this. What you do is you multiply this number times the negative 6, and that goes right here. So the coefficient of your x squared times your constant goes here. And then in front of your x is 1. So we just put a 1 here. Okay. Now, can you think of two factors of a negative 12 that add up to 1? 4 and negative 3. Very good. So 4 and negative 3 are my factors. Okay, so one of these is going to be 4x. One is going to be negative 3x. Now, when you have that 2x squared, what that means is I'm either going to have 2x times x to give me that, or I'm going to put the 2x here and the x there. How I know where to put the 2x, I think about if I put the 2x here, does 2 divide evenly into 2? And it does. Does 2 go evenly into 3? It doesn't. So that tells me I don't want my 2x there. And instead I want it here. And then if you check across, does 2 go into 2? And it does. Does 2 go into 4? And it does. So it's 2x times x gives us 2x squared. And then we think, what times 2x gives us 4x? That's 2. x times what gives me negative 3x, that's negative 3. And 2 times what gives me negative 6, and that is correct. Now, one of my factors is x plus 2, and the other one is 2x minus 3. Okay? So this one, I think you probably know by now. This would be the opposite of this, so it'd be a negative 2. Now, if I set 2x minus 3 equal to 0, I'd add 3, and I'd get 2x equals 3, divide by 2, and x would give me 3 halves. Now, if you like the shortcut way to do this, how you would do it is you would take the opposite of this, which is a positive 3, and you divide it by what is in front of your x. So you take the opposite of this and divide it by what's in front of your x. And that is the same answer we got here. Okay, so this is one answer. And then I have to say whether they're real or imaginary, and there's no i's again. So you would just say 2 real roots. Now, if we look down here, notice this one has two terms in it. And when it has 2 terms in it, the first thing you should always think of with every type of factoring is, could I take something out front? Is there a number or a variable that goes into both of these? And doesn't 2 go into 50? So I can take a 2 out front. And do you see how this has 3 x's and that has 1 x? I can take 1 x out front. And then I think 2x times what gives me 2x to the third, and that's x squared, minus 2x times what gives me 50x, and that's 25, and that equals 0. Now, is this difference of squares? Do you know what difference of squares? This has to be squared or to the 4th or to the 6th. This has to be minus, and this has to be a perfect square, which it is. So what I would do then, I just copy down that 2x. And remember, with difference of squares, you have 2 sets of parentheses. One is plus and one is minus. If this is x squared, we do x and x. And if that's 25, we take the square root of 25, which is 5 and 5. Okay. Now we have to do our answers. If you have something out front that has a variable, your answer is just going to be 0. And if you tried that, if you set 2x equal to 0 and divided by 2, your answer would just be 0. Doesn't matter if you have, any amount of number in front, it's always going to be 0. So this answer is x equals 0. This one, I can just do the opposite of this. And this one would be the opposite of that. There's no i's in any of them. So we have 3 answers. So we just say 3 real roots. Now, one type of, I actually should go back and show you guys this again. You guys have this cheat sheet. I don't think this is on your cheat sheet, which is good. We've done difference of squares. In this section, we won't do these 2. We've done trinomial factoring, you've seen that. But the one thing we haven't done is factor by grouping. And I know for sure Mrs. Deering shows factor by grouping different than I do. She kind of uses a box to do factor by grouping. So if you're used to that, do that. and you should get the same exact answer as me. Okay, so when you have 4 terms, you're gonna do factor by grouping. And if I look at this one, I have 4 terms, okay? So when I start this one out, when I do factor by grouping, I connect these 2 together as well as these 2 together. And notice I even put my parenthesis for the second one around the sign for that, because I certainly want to know if this number is positive or negative. Okay. Then what I do is look at this first thing and I look at what could I take out front. Notice this is 3 x's. This has 2. So you can take the smaller amount of x's out. So I can take x squared out. Then I look at x squared times what would give me x to the 3rd. If I need 3 x's and I have 2 here, that means I need 1 more. Okay. Then it's minus because of that sign. And I think, what would I have to multiply x squared by to get minus 3x squared? I already have the x squared. So do you get it would just be the 3? Everybody understand that? Okay. Now we're going to go to this. Okay. And I'm going to look at what can I take out of this? 4, right? Doesn't 4 go into 4 and 4 goes into 12? You could take 2 out too, but that's not enough. You want to take the highest number out you can. So we're going to take a 4 out. And we think 4 times what is 4x? That's x. Minus 4 times what is 12? That is 3. Okay. Now, when you've done factor by grouping this correctly, this factor and this factor should be the same. If they're not, you've done something wrong. And what you do, I always put that factor down first. And even though it's there twice, you only write it down once. So this has to be the same. You bring it down once. Then what you do is you take what is in front of this parenthesis and what is in front of this parenthesis with the sign, and I write that down. So I'd have x squared plus 4, and that equals 0. So again, this was written twice, but I bring it down once. I take what's in front of here and put it here, and then plus 4 goes here. Okay. Now we're to the point where we are going to solve them. And here's the deal. This one is just going to be x equals the opposite of -3, which is 3. So that's done. I figured out my answer there. This one is a little bit different. When you have 2 terms, you think, is it difference of squares? Is this difference of squares?
Yeah,
Can I do that if this is plus? For difference of squares, this has to be minus. When it's not, what you have to do is take that x squared plus 4 and set it equal to 0 and solve it. Okay. So when I go to solve that, I'm going to subtract 4 and I get x squared equals -4. Then do you know how to get rid of an x squared? You just take the square root. So I'm going to take the square root here as well as there. And x is going to equal plus or minus, okay? If this is -4, do you guys remember what you get if you have a negative under a square root? You need the I. So if you have a negative under a square root, automatically that tells me I have an imaginary number. And the square root of 4 is 2. So there's my answer. Now last try when I taught this. I was really surprised when we got to the test because a lot of kids didn't know how to count the roots and how to say if they're real or imaginary. Do you guys get this is one real number, right?
Yep.
That's easy. One real. Do you get that this is imaginary? And because it's plus or minus, do you get that's two different numbers? It means that it equals positive 2i and negative 2i. So this is two imaginary numbers. You don't really have to write root. I know before I was, but if you just said one real and two imaginary, that's fine. Do you guys get why I said two? That easy? Okay. All right, you have two more. So if I look at this one, again, the first thing I always do is see what can I take out front? What can I take out front of this? X, okay? Then I look, X times what gives me X to the fifth? X to the fourth, yes. Okay, and then that's a minus, so I'm gonna bring that down. X times what gives me 81x? 81. And it's equal to 0. Okay. So here's what I would do. Have my X, and I have to decide if I can factor this. Is this difference of squares? This is minus, right? This is to an even power. Is 81 a perfect square on the back of that sheet you have? It is, right? The only difference from this one, from what we did like the last couple of days, is this one has a 4 instead of a 2. So I'll show you how you deal with that. So it's difference of squares. So just like before, one is plus, one is minus. Okay. If this was squared, you know how you put an X here and an X here? If you have X to the fourth, you put half of those X's here and the other half here. And do you get half of 4 is 2? So you'd have X squared for each of them. Then you think, what's the square root of 81? 9. So you put 9 and 9. Okay. Now, this is equal to 0. Do you remember? Actually, let's do this. Let's try to factor these two more. Can I factor this one? And why? You're right, we can't, because it's positive. Right, I can't factor that, so I'm just gonna copy it down. Can I factor this one? Yes. So that one is difference of squares, okay? I know it's difference of squares because this is squared. I have a subtraction and I have a 9. So what I'm gonna do is go X plus X minus, okay? For the 3, you put the square root of that here and here, and square root of 9 is 3. Okay. Now, right away, I can get 3 of my answers. If there's just a plain old X out front, even if there was a number in front of it, one of your answers is X equals 0. So it's like if you canceled all of this, X would be equal to 0. Okay. This one would be X equals what? -3. And this one would be X equals +3. So there's 3 of my answers. With the other one here, what I have to do is set that equal to 0. Okay. So I'm going to take X squared plus 9 equal to 0. I'm going to bring the 9 to the other side, and it's going to become -9. It's X squared, so I have to take the square root, and I get X equals when you take the square root like that for these, you have to think that that could be a positive or negative number. And then if you have a negative under a square root, you have to take into account and what if you have a negative under a square root?
29.
I. And what's the square root of 9? 3. Very good. Do you get this is 2 answers because of the plus and minus? So how many are real here? 3 are real. And then how many imaginary? Yeah. So if I was grading this, I would grade not only the answers, but this part too. Okay. One more and then I'll be quiet. So here, if I look at this one, we're going to take out an X because there's an X in each. Then what I do is think X times what gives me X to the third? That's X squared. X times what gives me negative 4X squared? That is a 4 and an X. Okay, X times X is X squared, and then I need that negative 4. For this one, there's that minus, and I think X times what gives me minus 32X? 32 equals 0. Okay, and it would be minus 32. Now that I get to that point, if you use this, you would, this is a trinomial, so we try to factor it. So we'd put our negative 32 here and here, and our negative 4 here. Okay, can you guys think of 2 factors that give us negative 32 and add up to negative 4? 8 and 4, and which one would be negative? If this one's negative, the bigger one would be negative, so it'd be the 8th. So it'd be negative 8 times a positive 4, and negative 8 plus 4 is negative 4. So one of these is negative 8x, one is 4x. And then to get that x squared, we have x times x. And then to get negative 8x, this is negative 8. X times what is 4x? That's 4. And we'd have a plus there. So I still have that x out front. I can't forget about that. Okay. One of my factors is x minus 8, and one is x plus 4. Oh, if that x is out there by itself, what does x equal? 0. Then here x equals positive 8, and here x equals, yep. And then you have 3, what kind of roots? Real. Very good. All right, so we'll stop there today. And then I'll give you the worksheet. And honestly, it's not due till Tuesday. We'll have more time in class. Like you guys only have 8 minutes now. So you could certainly wait till Monday to do the worksheet. I'll tell you which ones you would work on if you wanted to. But Monday, I won't have to teach super long. So on here, I think what you could do. Why don't you just work on 1 through 4 if you want to work on something, and then we'll do the rest on Monday. Like I said, if you want to wait till Monday and do them all, you would be absolutely.